Good afternoon and welcome to today's Workplace Safety Academy webinar titled A Proactive Approach to Lift Station Modernization, sponsored by Mitsubishi Electric Automation. I'm Alex Cosson with Wastewater Digest. I'd like to introduce today's speakers. We have Wesley Gulick, who is Industry Marketing Manager, Water Wastewater for Mitsubishi Electric Automation, and Ben Strong, who is Industry Marketing Manager, Drive Systems for Mitsubishi Electric Automation. Gulick has over 35 years of experience, 25 of those years with Mitsubishi Electric in factory automation. Gulick's roles have included product marketing for PLCs, HMIs, and VFDs, Midwest Regional Distribution Manager, and several OEM verticals such as machine tool, material handling, automotive, electronics, HVAC, and water/wastewater. Strong has spent the last 20 years helping customers improve their processes and machines with automation. He has a wide range of experience across multiple industries with a focus on making things move. Team, over to you.
Thank you, Alex. And again, as Alex mentioned, my name is Wes Gulick, and I'll kick off this presentation. But we're going to go back and forth between Ben and myself. So first, thank you, and I'm going to just go with hello, depending on where you are in the country. It could be morning or afternoon. So again, hello and welcome. So our presentation is going to be covering, a proactive approach to lift stations. We're going to cover 5 different, topics. What are the current, challenges, that we're hearing in water, wastewater, improved pump and lift station, robustness, the advanced VFD, functions. What are the VFD startup, considerations that we should be including, and a little bit on SCADA. So I thought I'd include some USA, water facts. And with these USA, water facts, if you could take a look at the first one, that was, pretty astonishing that, critical process in the water, wastewater, irrigation activities jointly use 55 billion kilowatts per year, according to the Department of Energy. Again, I thought that was, very, very substantial. The other thing is, it's estimated that about 3 to 4% are being used by, water, wastewater, and 80% of that power is consumed by pumps and blowers, and that's essentially what we have, throughout the water, wastewater plants. A lot of pumps and blowers that we are controlling, and there's a lot of wastewater plants throughout the country. It's estimated about like 16,000 treatment plants in the U.S., and 76% of the population relies on clean water. And firsthand experience, I grew up in the Chicagoland area, 50 years, and the last 3-4 years in lovely Florida on the Gulf side, and with the 2-3 hurricanes of the last 3 years. Really, realized the importance of clean water. One of the hurricanes, we lost power, we lost, water. We're not able to, flush, no showers. So everything was essentially done via, bottled water. So extremely critical. It's a natural resource that I think, we should all be very respectful. So what are the current challenges? And these are the ones that I've, collected, throughout the years. But then I also did receive a report earlier this week from, Black and Veatch. And it parallels a lot of, what they're saying. As an example, with the first issue, they are saying the aging infrastructure is their number one issue, as well as the feedback nationally that I'm hearing is it's also the aging infrastructure. It's been put into place, about 50 years. Lift station as a whole is about, lifespan of about 50 years. But if you take a look at the control part of it, that's typically about 15 to 20 years. The other thing is, lack of professionals entering the industry. So as we're all, getting mature, a lot of us are going to be exiting out, and we don't have the younger crowd, being attracted to water, wastewater. So we're going to have to be smarter on how do we, manage water, wastewater, essentially, putting in more automation and controls. And then expanding regulations. So here we are, Ben and I were attending a hydraulic institute, and the previous session that we did was going through all the regulation, changes during the next, 5 to 10 years. And there's a lot of changes that we need to pay attention to. The other hot topic is the bioterrorism, cybersecurity, where it's critical. I mean, if someone does hack into your system and changes, the formula for the process for clean water, again, it can be a very, critical situation that we may need to resolve and correct for. The other thing is condition, asset management, especially in wastewater. And I've heard this in multiple times during different types of, seminars. Extremely, data rich, but very information, poor. So it's like, what are they doing, with this information? And that's, some of the things that we'll try to, go over. That the importance of, yes, we need to collect this information, but then, how are we analyzing it, and more importantly, what corrective actions are taking place? And the increasing, water demand. So this water demand can be for multiple, reasons. The system's becoming, less and less efficient, creating the increase in water demand. Geographies, like here I'm in Florida, a lot of growth taking place in Texas, as well as Florida, as well as California. So there's definitely an increase in water demand. And the rising cost, so depending on where you are at, it could be anywhere from 10 cents to 50 cents, per kilowatt. And that's not going down; it's just going to keep going up. And then the cost of recovery, it's all depending on, how quickly, things can be corrected for. So if there's a lift station, spill, there's some, significant penalties if that sewage, goes out into the rivers or to the lakes or just out in the population, the U.S., population. So we need to, pay close attention to that. The other thing, public understanding of the value of water systems and services, which I see firsthand. Public understanding of the value of the water resource. I mean, it's a critical, natural resource that we need to be very respectful of. And then with the compliance of future regulations and then asset management. So the three that we are going to be covering, primarily in this session is the lift station, failures. So over there we have a picture shot. In this case, it was a critical failure. That pump, as you can see, is being lifted, from the well. As you can see, it could be, wipes, it could be, multiple, different things, that are stuck in that lift station that are being, removed. And we did notice a huge spike, especially during COVID, 3-4 years ago. Those flushable wipes, not so flushable, and those were being, found in these, lift station, pumps and creating all kinds of, havoc and problems. The other thing with lift stations, which we'll be covering, is, the mechanical wear. These pumps are approaching, 40, 50 years and approaching, end of life. So we need to start paying closer attention to it, as well as the electrical panel. And that's what, our second point is the aging infrastructure, approaching 50 years. And we need to be proactive and start, making, changes as we move forward. And then the high energy costs. So how do we go about, trying to, maintain that energy cost? And it's simply, taking advantage of today's, technology. So I'll kind of reference back while this is fresh in my mind with the Hydraulic Institute. Here you can have, energy savings, using controls, the VFD as opposed to soft start or cross the line. But there's also tremendous, savings that can be realized using proper pumps. And that's what, one of the earlier sessions, this morning was about, efficiencies, specifically using, proper pumps. So here we have a, timeline of the aging wastewater infrastructure. And it started back in, 1969, and it started, with that, river. It was catching fires multiple times. But in 1969, it started catching local, regional, and national attention. And that's when a lot of these acts were put into place. A lot of the policies, procedures were put into place, standards. And then in turn, a lot of the lift stations, were put into place, starting, from the early 90s upward to, 2025. So we have a polling question. What grade would you give your lift station? A+ means experiencing no problems, while an F means experiencing constant failures.
this should be pretty interesting because we speak with customers and some customers say, no, we have a plan. Well, we know what we're going to do next year. We know how we're upgrading. We speak with other customers say, we don't have a plan. We're a small municipality. We have 20 or 30 lift stations. Our main technical person's getting ready to retire. So we all think we're better than the national average. Kind of like my children, we're rating ourselves higher than what the American Society of Civil Engineers rates the U.S. We'll show you guys that slide here in a second.
All right, so the results that we are reporting is with the A+, we have about 6% there, but the majority are coming in at C with about 48%. B was 24%, and D was 6%, and then F was 2.9%. So pretty interesting. And then what we have with our next slide is was it 3 years or 5 years?
I think it's every 3 years that they publish this. The American Society of Civil Engineers goes out and rates America's infrastructure, and they've separated wastewater from water. And they go out, and each individual state will also receive a grade. And this is a general idea of how the Americans engineering folks think we're doing.
Community here.
Yeah, the civil guys.
And I'm noticing, there's definitely, brown spots, down in Texas as well as down in the, southeast. Then we do have that, orange, red, but, D grades are critical areas that, need, improvement. So just FYI, keep that in mind. So the next slide is, consideration for future-proofing, pump and lift stations, for, migration. And some manufacturers, definitely do better in this area than others. Like the PLC programs, how easy are they to move from, let's just say the 2000 vintage to the 2025, this year's, vintage. The VFD parameterization. So there's definitely some manufacturers that do all their VFDs. So the point that I'm trying to make over here is when you are evaluating and trying to move forward, first of all, hey, we want to implement, variable frequency drives as opposed to soft start. The manufacturer that you are, investigating, exploring, ask them, number one, do they do all their VFDs? Do they manufacture all their VFDs? And then are the parameters the same from 30 years ago? And there will be some manufacturers, specifically, one comes to mind, that the VFD parameters have been the same for the last, 40 years.
And to put that in context, why should I care? The average life of the mechanical system of a lift station is 50 years. So in the 50 years of service of that device, you should expect to upgrade the controls 2.5 times, depending where you hit and how reliable the products you use to upgrade those lift stations. Another consideration is networks. There's tons and tons of municipalities still using serial. If you had a vision into the future, would you have implemented Ethernet 10 years ago or 15 years ago for your municipality? So that's things to think about. What about cost of ownership, Wes?
So yeah, with cost of ownership, there's, the energy efficiency. That's one component of it that, come into play, such as durability. What type of, warranty does that manufacturer have? What is their mean time, before failure? So some manufacturers, will offer, a 5-year warranty, which to me, is a pretty compelling statement on, why should I, select, do with, their how durable their system is.
And we'll talk about warranty a little bit more in detail. Just because it says 5 years, that doesn't mean that's 5 years parts and labor. When we start breaking down what does it cost to repair or replace a pump, those are all things we have to think about.
Very good point. And then with VFD, optimization. So, the VFD, we're starting to hear people calling that, a sensor, and they're becoming smarter and smarter. There's tremendous amount of data that you can, get from the variable frequency drive, send over to a SCADA system and start doing, proactive, preventive. So it's extremely important to utilize the VFD to its full capacity. And then the commissioning. With the commissioning, there are some manufacturers that will offer, factory, commissioning, because typically they feel that, hey, the factory is going to be, the expert. They're going to be as well as, optimizing that system to my, station, my pumping station. And then, what type of monitoring are you looking for? What is there a SCADA place or SCADA system in place now, or are you looking to implement one? And then the Predictive, they are in place, but then in turn, you need to kind of close the loop, even though this data is coming back. What do you want to do with that data?
Absolutely. I think most modern devices will predict their own death, but sometimes we don't use that information, or we're not aware that our drives and our PLCs and our HMIs all have these features. Forward migration considerations. One of the things that you should really think about asking vendors, the product you're going to use in my lift station, where is it in the product lifecycle? This happens in other industries where all of a sudden somebody needs to get rid of a bunch of stock, and you see a stamping press come over and old. You want to time where you are in the product life station. If you're at the very beginning, sometimes the leading edge of technology can bleed a little bit, and you can go suffer learning curves. If you're at the very end, you might find yourself on this treadmill where you're constantly reworking things, where you never get to do anything new because you're constantly upgrading and revising your existing lift stations or your existing processes, right? And that's not very fun. One of the things to think about too is software capability. In municipalities, we have to have a long-term, and this is how long these lift stations typically are designed for. Most municipalities are planning out 5 to 10 years with what they're going to upgrade. Well, is the software you're using today going to be compatible with the software that vendor offers 5 years from now? Questions to ask. Communications, and especially if you're on a serial-based communication platform now, going to the future, do I need to be on Ethernet, or my vendor and my scheme, my control scheme, is it going to grow? So you have to choose the right formats and how you communicate. And changing regulations, right now that seems to be less of a risk, but it does change. We've seen it in the HVAC industry where VFDs are being adopted basically across the board because of changing regulations. Is that something that your industry may adopt? And then the point that sticks with me the most when I speak with customers in the water wastewater industry is I'd like to get off the rat race. Let me off the treadmill. I don't want to keep redoing this over and over and over. It feels like every time I turn around, the product's gone obsolete. I have to change it out. And it's re-engineering something that already works. So it's not really added value. They just work for the sake of work. So those are things to consider. And then talking about cost of ownership, it's pretty much broken down into three major pieces. There's a couple ones that aren't negligent, but not the main contributors, right? So the initial cost, the cost to design, engineer, commission a lift station is not an insignificant piece of the total cost of that functionality that we're building into our collection system. And then energy usage, which for a lot of operators doesn't really matter until you tie energy usage to cost. So when it comes to energy here in the US, the Department of Energy is expecting it to increase at an annual rate of between 11 and 14%. The national average is at 13 kilowatts an hour, but that's something that we expect to increase past the rate of inflation, which is interesting. And also, I don't want to have to increase rates to my users, but energy is getting more expensive. Cost of operations getting more expensive. And that last piece, repairs and maintenance, can we avoid them? Can we identify problems before we have to repair them and they cost more money? Some of these pumps, and nobody wants to replace those pumps if you can avoid it. So here, talking about the different technologies you need to consider for starting your motors. We've heard arguments from smaller lift station operators, smaller municipalities, maybe it's more rural, maybe it's older, that, I really like a contactor to operate. Just my pump only turns on, it only turns off. A contactor is binary, it's very easy. But there's some drawbacks to just operating on a contactor. All the information you'll ever get back out of a contactor is it's on or it's off, unless you add current transformers. And if you look here at this curve, you can see when I'm starting this pump across the line with the contactor, how much current of the motor's rated full load amps is going to drop. And so that's why we created soft starters. We don't want this huge jerk. We don't want the motor to take all this power instantaneously to try to accelerate to 60 hertz. So we use soft starters, and it's a little better. We don't have as much starting current. We don't have as much information about how the motor is operating. But the best choice is using a variable frequency drive. And the reason for that is you can control the ramp up. You don't have this huge change in pressure that translates into shock waves, that translates into slamming check valves, or these huge transients that can damage some of these systems. Like we said, if your piping system's 40 years old, maybe you don't want to be shocking them every time your pump starts. So these are things to consider about what technologies you put into your lift stations.
It's a very, very, good point. So, I mean, as you can see, from the simple, on off, very easy to control, but very simple, results to the variable frequency drive. And with the variable frequency drive, that's where you have, control over that entire range, as well as the higher efficiency. In your previous slide, you talked about, energy usage, and there's different, cost initiatives, that are taking place, as well as, grants and funding, where if you are, saving and can showcase, 20, 30%, energy savings, that can be in turn, a rebate, for the end user, for yourself, as well as, I know the typical, operator may not care about, the energy efficiency, but this is something that, the owners, the upper management are paying closer attention, because they are seeing the end of month, what that, bill looks like.
Absolutely. So here, if you've been in wastewater, I'm sure you're aware of the pump affinity laws. But the point we're making here is, if we're comparing a pump that operates at 60 hertz across the line, that we can't vary the speed, and therefore we can't vary the flow rate without a bypass or a throttle valve. A VFD, by comparison, allows us to operate and move the best efficiency point for that system back and forth. So here, speed's proportional to the motor speed. Power is cubed. So we slow down a little bit, not below the max of the minimum speed for your pump, because most of our pumps have minimum speeds, and we have the operational range that we've calculated for this pump where we want it to operate. But if we slow it down a little bit, we reap huge amounts of savings in power, some up north of 20% if we're running steady state. So that's something to keep in mind. So here is an estimate that was done for a customer in Hawaii. Their power is very expensive. I said the national average here is about 13 cents a kilowatt. On the islands, it's 42 to 50. So for a 100 horsepower pump using the pump affinity laws, we convert that to kilowatts. We reduce the speed 80%, still keeping our frequency above the minimum speed for that pump. We calculate our energy savings, and then over the year, in Hawaii, they could expect $143,000. So if that pump were operating here in the the continental U.S., the number would be closer to somewhere between 20 and 40, depending where you're at and how much that pump ran. So those are some pretty compelling numbers, depending on which input you put into these equations.
Correct. Yeah. So I mean, this quick feedback point. I mean, with that return, I mean, again, in Hawaii, they made a decision like within a week. It's like a no-brainer, because the return on investment, we're talking months, not years. We're talking, within 4 or 5 months. So definitely something that they went from, soft starts to variable frequency drives to take advantage of the cost savings.
Yeah, you do have to do the engineering on this. You have to ensure that your system can take a lower flow rate and a lower frequency and still do what you need to do. But here's an option for you to save money. So another poll: what control method are you using to control your pumping systems? I'm always surprised how many people are using direct online starters. I'd be curious to learn, are we using direct online because we have single phase input, or Are there other reasons we use it? It's what we have. It works. We don't change it out. I understand it. I'm curious to learn.
Yeah, so the results, if I could read them off. So the first one, the direct online, we're looking at about 39%. Soft start is 41, very, very close. But variable frequency drives are used at 58%. So it seems like the majority of the systems out there are VFD, but it varies, from region to region, percentage-wise.
So when we start talking about robustness, there's a couple ways to look at it. We can look at it from a mechanical standpoint, where we say if we operate as close as we can to the best efficiency point, we also operate with the least amount of risk mechanically with regards to having a system that cavitates or having a system where it uses too much power for the flow rate. There's other things that can make your lift stations more robust. Almost every VFD manufacturer in this space that builds a pump drive has advanced VFD functions that when we ask operators, are you using this function? Are you aware of this function? Probably 60% of the time we're told no, which really surprises us because it's built in. You have it, whether you use it or not, but sometimes people don't use it. The predictive maintenance functions can be really powerful as well. We don't think of that as much in water wastewater. Hey, we monitor it. The SCADA system gets the alert that this lift station's down. We send the message out to the tech and he fixes it. But how much more efficient would your organization be if you could schedule that call instead of having to react to after the lift station stops pumping water? Automated corrective actions or functions. Almost everybody's VFD has things that will correct certain problems with your lift stations without the need for a tech to go out there. Now, not saying it's 100% or it's bulletproof or go ahead and we don't need technicians anymore. Not by any means, but we can make their life a lot easier. Drive and motor protective functions, that definitely something we can do with the VFD. Hybrid integration, that's something we have to do or consider as we're operating our lift stations with VFDs if we choose to go that way. And bypass operations, if the VFD doesn't work, do I want to have contactor bypass or a soft start bypass? How redundant, how reliable, how do I want to make my lift station operate? And we can't really talk about water wastewater without talking about cybersecurity. The federal government is helping us. They're pushing more and more efforts to make sure that our infrastructure is secure from foreign hackers. And I'm all for that. I don't need to wake up in the middle of the night and see the lift station down by my house overflowing. So here, talking about advanced VFD functions, this first one, AI fault diagnosis. There are manufacturers that are starting to put machine learning, not full-blown AI into drives and components. Well, some more of the AI is starting to find its way into PLCs and how we operate those. But specifically for VFDs, the way AI is being implemented at the device level is the drive can learn your application and the drive can start helping you troubleshoot. So if you're using a drive, a lot of times we have a display where the drive's going to tell us in clear English, I have an overload. Well, if you have a drive with AI on board, then the next thing you may read on that screen is there's an overload condition, and here's the probabilities that this is going to fix it. Normally, we just list them out in the tech manual, and you go 1 through 6 and try to figure out. If you have some experience, you jump to the one you think it is. If you have the AI, it'll point you to the one it's most likely to be as a corrective action, and I think that's very powerful. Other things, the Department of Army Engineers, the Army Corps of Engineers, they're recommending for pumping stations that you have motor winding preheat, so we don't build up condensation in the motor's windings so that we don't degrade that insulation. Pre-charge, soft build, manufacturers have different names for it, but basically we don't let the drive go into PID control until the discharge pump is full. That prevents water hammer, huge differential in pressures, check valve slam, those kind of things. Dry run prevention. Again, most VFDs should have this function, and we should implement it. There's no way to tear up a pump faster than to run it dry. Motor temperature monitoring, and we can pull that information into the VFD. We can pump that up directly to the SCADA unit, or we can collect it in a PLC to gather that data and then push it up however we choose to communicate with the overarching control. And that moisture monitor sensor, it's important that we hook that up and then we monitor it, whether that's through the VFD inputs or if that's through a PLC. So
it looks like, the VFD, as we said earlier in the presentation, are becoming, smarter and smarter with a lot of these, advanced VFD functions. But I'm also, hearing that with the latest, releases, they may have like component, monitoring actually on the variable frequency drive. So I think that's kind of taking it to the next step, a level that, hey, your fan is, approaching a 10-year life cycle or 10-year lifespan.
You've cycled your capacitors to the design life, right? A lot of manufacturers design their drives for a 10-year life cycle on their capacitors. And that also is a number of energized cycles. So the drive will count those and say, look, these capacitors are, I hate to say wonky, but when you're at the end of life, it's maybe they last another 5 years, maybe they go. That information is available to you, and your drive can ping you and say, well, I am at the end of my design life. Then it's up to you to make the decision, how much past that calculated design life do you want to run the VFD?
Risk tolerance. What's your risk tolerance? Huh?
Everybody's different. So load characteristic monitoring, most VFD manufacturers have something like this. Earlier, I was talking about AI, or where the VFD can learn your application. So it's typically 5 operating points that you can either set or the drive can measure about your operation, and then defines a normal operating range. So if the drive deviates from that normal operating range, high or low, most of the VFDs will let you choose whether to warn, just a discrete bit, hey, I'm out of my normal range, or fault, where the drive turns itself off. When would I want the drive to turn itself off? For instance, if I were turning at my maximum frequency, 60 hertz for a pump, and I had no load, I would want to alert someone, because that's an indication that my coupling broke, or I don't have, I might have a blocked suction on that pump, and it's just free spinning, and I'm not moving any water. On the other part, if I have high load at low speeds and it trends all the way up, I may have a bearing starting to fail. I may have a fouled impeller. There's other things that we can infer based on monitoring this. This is in most people's drives as a standard feature, but you have to turn it on. So something to think about.
Key point, right? Turning it on.
Other corrective functions, a lot of drives have, I've heard it called anti-clogging, I've heard it called cleaning, I've heard it called deragging. I think it depends on the VFD manufacturer and where they're coming from. Also, auto start or auto restart after fault. If you lose Ethernet communications, do you want your drive to come back up? Most drives will and run. For instance, if you lose Ethernet communications, do you want your drive to run locally? If that's the answer is a yes, then ask your manufacturer. Most drives will do that. What I'm showing here on the right side is to catch a spinning shaft. So if I'm operating the pump, I lose power in the middle of operation. If I take these advanced functions and I use them, I can catch the motor shaft before it slows down when power is restored and speed it back up. If I'm doing this across the line, I have to make sure that pump is stopped before I close those contactors again. Otherwise, I'll have a VFD at a speed, and I'll be trying to instantaneously take that and bring it up to 60 hertz. It's not a good thing for your mechanical system. Here's a typical anti-clog or deragging routine. I think the most important thing I've seen with this is you have to know if your pump can be reversed. If not, that doesn't mean you can't use an anti-clog routine. It just means don't reverse your pump. And you have to understand mechanical systems to implement it. There are systems you shouldn't implement an anti-clog routine. There are pumps you shouldn't rotate backwards. Most of these drives, an anti-clog routine is configurable, so you can cause it to oscillate. And what that does is it pulls the fouling or the material and blows it back out the suction, moves it around, dislodges it, gets it so that that material can transfer out of the pump. What we recommend to customers is these triggers are ORs. So don't just say, well, I only want to run an anti-clog routine when I get a load warning. Back to load characteristics. If you set it up and use load characteristic monitoring, then you can trigger this routine on high or low alarm points, right? But if you also say, every 24 hours of runtime, run this routine. Every time on startup, run this routine. what you can do is you can proactively remove fouling from that impeller and possibly move things from the suction before they get in and start fouling up your pumps. So we recommend more than one trigger. These are ORs. You could configure all of these triggers. We've had customers that use an input right on the screen with a push button. So if the lift station isn't flowing when it's supposed to be, they go out there, they trigger it, the cleaning routine right by the push button. Some of these people who operate lift stations, they can tell by sound it's not right. I'm driving by it doesn't sound right. And they've been doing it long enough. They know they have to go back flush that pump or take action. Here, they just press a button.
We hear that pretty much at a lot of different municipalities. They've been doing it for the last 30 years, so they know just by sound where the problem's at. The thought kind of going through my mind is, with manufacturers, how easy or how difficult is it to set up, these cleaning anti-clog, routines as an example? Are we talking, a half a dozen functions, or are we talking 1,000 lines of PLC codes?
Now, with the VFDs that we use, it's one parameter. You enter a number, it represents the number of triggers and what types, and away you go.
Very easy.
It's one or two parameters. It's pretty clean. So other considerations, motor cable length. This comes into play, not as much with lift stations where your VFDs may only be within 25, 30 feet, but something just generally, if I'm implementing a VFD or a motor, motor with VFD, kind of have to have both, right?
Yes.
But the motor cable length is a consideration. Some manufacturers can go farther than others without adding additional filters to deal with the voltage spikes that can happen at the motor terminals. This really surprised me, but in water, wastewater, if you're retrofitting a lift station, you need to check the motor installation rating on your pump motor, because there are still manufacturers out there that make motors that aren't rated for VFDs. So if you're using a motor that's not rated for VFDs, you can actually get burned through on the installation in your windings, then you short your windings, and then the motor doesn't work anymore. So filters, motor cable lengths, for some places, harmonic mitigation, depending how big your lift station is. Those are all things we have to think about as we're modernizing our lift stations. For startup, a couple of things that I think are key to know going in. One, who's going to start it up? Do you want the factory startup? For most manufacturers, if you do a factory startup, it does improve your warranty. It will generally improve your results. Two, auto-tuning. Why would I auto-tune a drive if I'm just going to operate it in volts per hertz? If I'm only going to take the drive out of the box, configure some parameters, and start it, why do I want to auto-tune? Well, auto-tune lets the drive calculate the resistance from the length of the motor leads as well as the motor data. And that becomes important if you want to use the advanced functions or if you want to use the VFD as a sensor and start monitoring more information. If you truly want to know how much torque it takes for your application, not current torque, you have to auto-tune that drive. And mode of operation is important. For a lot of lift stations, we think, well, our VFD is just a shaft turner. Let's just keep it simple. Let's keep it volts per hertz, which is fine if you understand the ramifications of that decision. But if you're operating where you need more torque, what you may consider is switching to like a Flux vector mode that requires an auto-tune. Things to think about on data collection is how is the data going to get up to upper level control? How am I going to collect data and then make it useful? So there are schemes where I have a VFD, I have a PLC, I take the data to the PLC, and then I collect it, aggregate it, and push it up to the SCADA system. But with most VFDs, you can have it connected to a PLC and to the SCADA system, so you can choose that rate. Which path does my IoT type information with regards to power consumption, runtime, things that aren't process critical, but are needed to make informed decisions about how your lift station and your collection systems are operating. And communications, how am I going to communicate? Is it going to be over wireless? Is it going to be 900 megahertz? The lift stations in my neighborhoods, they're very steep neighborhood, so they have to deal with trees. They have to get line of sight for their radios because they're using 900 megahertz radios going back to a water tower. So those are things we all have to consider when we're upgrading our lift stations.
So with the auto tune, based on what you said, it seems like all motors should not motors, VFDs, we should implement the Autotune, but it doesn't happen. It seems like they start it up and just, leave it be. So,
and sometimes good enough is good enough, right? But if you're going to go to the next step and make your lift stations more robust and get it to ride through some of these problems, taking the time to auto-tune and startup can make a big difference on the longevity of that drive and pump. Any information that you get out, when we talk to people about we have tons of information, but we don't know what to do with it.
Yes.
We have information, but we're data poor. Some of the information you can get out of the VFD are pertinent to the way that system is operating. So some of the benefits, if you get a factory trained technician or an engineer on site, he can start that up. He can confirm, yes, it's communicating. Yes, I'm sharing data the way I'm supposed to be. Yes, I can auto-tune this drive. I can optimize your performance. Yes, I can help you set up your anti-clog routine if you'd like. It also means that you don't need to have skilled labor on staff all the time. Maybe your skilled guys are off doing something else. So you can basically a force multiplier where you can get more done. For different manufacturers, they have service areas where you can get coverage outside of that. And basic training, troubleshooting, onboarding to that product can all be provided during the factory startup. So other reasons to auto-tune a pump drive: increase stability. Well, what does that mean? It means the drive's going to hold a constant speed and it's going to be more accurate. Does that matter as much in lift stations? No, but that's one of the benefits. Improve slip compensation, so it's going to run with less energy. We mentioned it enables all the enhanced functions. We didn't even talk about all the different things a VFD could do. We're going to run out of time. Improved torque at low speeds. I recently worked on a pump that had a lip seal for the seal, and it wouldn't actually start in volts per hertz. So we changed it to a flux vector mode, and we created enough torque so it would overcome that static friction from the lip seal. So other reasons, it's required for flux vector motor control. So higher efficiency, more accurate control of your motor, all good things. Here's basically an outline of the difference. I didn't really outline volts per hertz. Typically if you take the box out of the box, it's defaults to volts per hertz. So for this frequency, we output this voltage and we don't have any feedback. So we don't really understand how much current the motor's using. We don't understand if the motor's even spinning in volts per hertz mode. If we switch it to a flux vector mode, we can do the calculation on current, and the drive will divide that current. And this is the amount of current that's required to create torque. And this is the amount of current required to energize the motor so I have a magnetic field. Once I know that current, the drive can compensate the voltage and frequency so I get more control, increase torque at lower frequencies, and I'm going to use the energy I'm putting into the motor. I'm going to be more efficient.
So empowering, operations, teams. So we're noticing, more and more, users are implementing, some sort of, SCADA system. And we're just listing, primary reasons, why, more responsive with real-time, updates, analytics, and reports. Because again, it's online, so you see firsthand, what the issue is, and firsthand, correct, pretty much immediately. And it's ongoing visibility, empowers, operators to, respond proactively as opposed to physically maybe going out there and hearing, hey, I hear this sound. It's probably at this pump or a temperature issue. Fix issues before complaints or equipment, failure. So kind of like what Ben talked about, more of the preventive, predictive, maintenance, where there's tremendous amount of, information that you can gather from the variable frequency drive. But, what do you do with that is a key discussion that's taken place during the last, 3 to 5 years. Reduce, response times, reduce, operating costs, because again, it's already implemented in the system, and you typically can, make changes, or there's changes that are already recommended in your SCADA system on how do you, correct, that issue, which improves, the response to issues and improves the regulatory, performances, as well as provides, risk management, which is a very key point when we talk about SCADA.
Last but not least, my favorite subject, cybersecurity. The world's changing around us. It used to be we could do the castle and moat where we would wall everything off either through a VPN, or we would say we're never going to let IT access to our OT systems, or we said we're going to let access through our moat with a VPN, but we're going to limit that access. And in today's world, that's not enough. So there's some key concepts that you have to consider when you're upgrading lift stations and how they fit into your overall network at your municipality. Current methodology to avoid cyber attacks, one of them would be the moving target defense. So if I never store data in the same place, it's very difficult for an outsider to find the data or the button to turn my VFD on and overfill my water tank. It would be one way to go about it. Another way, virtual desktop. We see this with some of the large corporations where they're like Microsoft, where they're enabling us to have virtual desktops where if there is a problem, we do have a risk or a vulnerability that's exploited on that desktop. It's virtualized, so we can close it, isolate it, and keep that threat from propagating through the rest of our network. And last, but most importantly for our space in the operational technology space, is zero trust. Just because an IP address wasn't malicious yesterday doesn't mean that same IP address can't be malicious tomorrow. So you don't trust anything. You assume that your moat's dry and they can walk right up into the castle and climb your walls. So those are concepts that if you're not familiar with when you're upgrading lift stations, you should consider them and decide which one works for your municipality as an overall scheme and how to prevent a malicious actor from gaining access to your lift station, especially the one in my neighborhood. Please.
Yes. We have another, polling question. So does your municipality have a 5 to 10 year plan to address aging infrastructure?
It's the easiest question we've asked so far.
Yes.
Everybody needs to answer yes.
So the feedback was, yes to that, question. They do have a 5 to 10 year plan, but the one that followed afterwards is, 22% is not sure, and 14% said no. So this is an area where your partner can help you with creating this 5 to 10 year plan. So always keep that in mind when you're talking to your partner or potential partners moving forward.
Right. So 55% of people have a plan.
Yes. Very good. Totally.
Doing better than I am.
Mm-hmm.
So if you have a plan, please consider Mitsubishi Electric, how we can fit and make that plan better and easier to implement. We offer products from VFDs, PLCs, HMIs, SCADA with Iconics, a very broad integrated offering. If you don't have a plan, please reach out to us. We would be happy to participate in creating one. So with that, I believe we're ready for questions.
Yes, Q&As.
Yep.
Mm-hmm.
Yep. Thank you, Ben and Wesley, for that presentation. A few of you have already submitted questions, so we're going to jump right in. So our first question from our audience that we have here is, how difficult is it to auto-tune a VFD?
It's relatively easy. Basically what we want, there's usually two methods of doing it. One, a static tune, or two, a rotary tune. In a perfect world, we'd always rotary tune our VFDs, and we'd spin the load, and it would come up with the resistance and inductance for that motor. Now the static tune routine is really powerful. The motor's hooked up to the load. You want it wired to the leads, the link that they're going to operate. And you tell the drive to implement the routine. It takes about a minute and a half.
Awesome. Thank you. Our second question that we have here is, are there any typical challenges to consider when installing a new control system?
Oh, yes. Yes.
Where do you start?
There's an awful lot. And we hit the high points as best we could through the webinar. How am I going to communicate? What's wired to what? Usually when you open an old panel and maybe you have electrical schematics, maybe you don't. Usually it's a rat nest. So there's a lot of challenges. Identifying what you have and how you want to migrate is definitely it can be a process, and we can help make it simpler.
Awesome. Next question we have is, can VFDs be used to convert from single-phase power to three-phase power pumps?
Absolutely. So the way a VFD works, we take AC power in, rectify it to DC. So if I have 230 volts coming in, I'll create a 300 volt DC, and then I'll use our integrated gate bipolar transistors, I always get that wrong, the IGBTs, to create our PWM to output a three-phase frequency. So VFDs, if you have a single-phase incoming power, you can open up the range of pumps you can use if you combine that with a VFD.
Right. Next question we have is, do you have a horsepower threshold when you should consider soft starters versus VFDs? And they said, we currently use a 30 horsepower as the breakpoint.
So the way I answer that is I do not. I recommend VFDs for everything. One, because that's my job, but two, because I like that flexibility. If I'm only using the VFD to start the motor and it's a very simple application, then do I need a VFD? Not really. But if I need the other features that come in, do I need the communication? Do I need to know if my motor's getting ready to fail, or if my drive or my motor, my pump is operating outside of that normal range? Then yes, I would use a VFD. But for the power, everybody seems to have their own opinion. We talk to guys like, well, my breakpoint's 50, my breakpoint's 30. We want to see a VFD with a soft start bypass at 100 horsepower. Just every municipality does it differently.
Awesome, thank you. Next question here is, what do you think about the use of VFDs in lieu of soft start? Any opinion?
Oh, I'm very opinionated again when it comes to this question. And I suspect my answer would be slightly different if Mitsubishi made soft starters. Personally, I'm spoiled. I work in more industries. I really like the ability to vary the speed. Sometimes just going 65 hertz is enough to get you over a hump. Sometimes slowing down makes sense. They both have their place, but the way we're seeing it is we have a lot more opportunities replacing soft starters with VFDs, because the ease of implementation, the way the VFD communicates data back to not only the SCADA system, but the operators, is improving. So I'm biased towards VFDs. And the reason I'm biased for VFDs is I get more information and I have more flexibility.
All right. Next question we have here is, what percentage do you see of VFDs that have electrical bypasses, whether that be across the line, soft start, or VFD? And they said, we mainly have small horsepower pumps here in rural Texas, so a costly endeavor to get this built-in feature.
And I could try to answer this question. So it's definitely, changed over the, last, 20 years. I mean, the variable frequency drive technology is becoming much, much more reliable. I think that's one of the reasons why, bypass systems were put into place. So with the electrical bypass, and it also, depends on the application, the process that, hey, I cannot afford the system to be down. So this is the reason why I will put in a bypass. Now, they can, I typically see it, with the soft start, typically across the line. It's just not the best way to turn on your system from a mechanical standpoint. The slamming, because it's either on or off, as well as from an energy efficiency standpoint.
Yeah, and a lot of lift stations are redundant or twice redundant with three pumps. It depends if the pumps are there for additional flow, for like a combined sewage outflow, or if they're there for redundancy. We've spoken with municipalities, and it kind of makes me laugh for this. We want the contactor bypass because I know I can flip the switch and I can see those contactors pull in. So it comes down to how comfortable are you with the technology, and who's troubleshooting it when something goes wrong.
Right. And then our last question that we have here, what kind of energy savings or ROI can municipalities expect after upgrading to VFDs?
I guess it varies. So depending on that, power cost, But we're seeing, generally speaking, VFDs is going to be a 20 up to 40% energy savings, and then you just need to do the math just to see what that translates into with respect to dollars.
And that's one of those things that for a specific application, we can help dive in and qualify that number.
And that concludes today's presentation. On behalf of Wastewater Digest, I'd like to thank Mitsubishi Electric Automation for sponsoring today's event, and of course, all of you for joining. Have a great rest of the day.
Thank you, everyone.